All right, we are starting chapter 9, and this is going to be the trigonometry chapter, although we're not going to start with anything that is going to resemble trigonometry, to you guys anyways. We're going to start with something you should have done, and you probably did it in like 7th grade. Okay, so we're going to start with the Pythagorean theorem.
We touched on this last year before the pandemic.
Yeah.
Maybe in the pandemic.
We're going to go a little bit further with it than you would have done, but it really is about the same. So we do have, if the title of the section is Pythagorean theorem, we probably should go ahead and write that Pythagorean theorem down. We also have 2 more theorems on here that we need to write down. And so this is on page 416. Because we're going to have the Pythagorean theorem, we're going to have the converse of the Pythagorean theorem, and then we're going to have the Pythagorean inequality theorem. And honestly, I'm going to just write the Pythagorean theorem, and we're going to take those other theorems, and we're going to write a table with it, so you have it. But just know it comes from 2 theorems. And I'll go ahead and get started on that table, so you will have it. I can't pick up my ruler. All right, this is very quiet, but that's okay. We're going to get all of this stuff done. And that's okay. So this is the chart that I want you to do. Of course, I haven't filled out the other part of the chart. I'm waiting until you kind of get your Pythagorean theorem done. And then we're going to kind of use our logic to see what we think about this. And I will get the door since I'm recording. Very exciting stuff. Oh. I'm not going to say a name on the recording, but I have something for somebody, and we'll do that after I put stop. Alrighty, let's look at this. This is, c squared equals a squared plus b squared. It's kind of written backwards from what you normally see it, but it works really good for this chart, and it works really good for the test on chapter 9. This is the Pythagorean converse. If you have a situation where c squared equals a squared plus b squared, that is going to be a right triangle. Okay? A lot of times we do, in real life, we use the converse more than we use forward. Because a lot of times they have to prove that the triangle is a right triangle. Of course, here's the vocabulary for my triangle. Your A and your B are your legs. and your legs are part of the right angle. Opposite the right angle is your hypotenuse. A lot of times I don't like to say hypotenuse because I get tired of it, so I call it a hypermuse because that's more fun to me to imagine a very, very sugared up moose. And if you've ever been around a moose, they're very funny, dangerous creatures. Has anybody ever been around a moose? Okay. We don't have very many, is it moose or meese? Moose. It's moose. Plural moose is moose. I wish it was meese. So in Oklahoma, we don't have a lot of meese running around, right? But, Northwest, every once in a while they have a moose that walk through town, and they're goofy and funny until you get too close to them, and then they're really, really angry. So that's what I like to think about as, hyper moose. So that has nothing to do with anything other than a story. All right, let's see if we can make sense of this. So let's imagine that the C, and it goes in this order. C is always the longest line. Usually you do A is shortest, B is medium, C is longest. It actually doesn't matter about A and B, but C is always the longest line. So if you see a set of numbers like 3, 4, 5, which one is the hypermuse? This one. Always the longest. So let's imagine if this line were to get shorter. What kind of angle would it be? And so I can just redraw this where that line is shorter. Okay, now that line is shorter. What do we think? What kind of triangle would this be? So if the C is less than A squared plus B squared, what kind of triangle would it be? It would be a acute triangle. Which only leaves one answer for this one, which is? Okay. This is probably the new stuff. The original Pythagorean theorem, which I probably should write someplace on here since this is a video, is A squared plus B squared equals C squared. Okay? It doesn't matter if you do it forwards or backwards. This, oh no. Thank you. This is kind of how I do it a lot of times when I do the opposite, just because it makes more logical sense if you start with the C squared. Equals is right, less than is acute, greater than is obtuse. So that's what I want to do on that. And honestly, there's not a lot more to this chapter other than doing examples. And we're going to do examples until it's time to leave. And that's what we're going to do. So let's look on page 441. And let's look at 3. And I'm going to draw the little triangle real quick.
441?
Yes, 441. So basically just turn the page a couple times. All right, there's 3. And it is a right triangle. And I think they gave me all kinds of good information about this. That's a 28. That's a 45. That's a 53. And wow, that is not 3 at all. And I told you the wrong page number because I was getting ahead of myself. Yeah, no wonder you asked that question. We're on, 420, right? 420. So this is a pretty triangle, and we'll come back to this at a later date. The real triangle that we should be focused on looks like this. And that's 7, 11, x. So we got to find the x. Okay? It's easy. The first thing you might probably need to identify is what is x. Well, this is A, this is B, part of the right angle, so this would be my C. So it doesn't matter which order you do it in. You can do it in x squared equals 7 squared plus 11 squared. Or you can do 7 squared plus 11 squared equals x squared. Doesn't matter at all. Okay, so we can just move on with our lives here and just solve. Calculators are nice. Even without a calculator, you should know 49 and you should know 121. X squared equals, and this would be a 170, right? Okay, this is math, so we pretty much want to do exact. Okay, so what is the square root of 170? Because isn't that the last step, algebraically? So x equals what? Do we have it?
It's like 13 point.
I don't want the point, I want the exact. I want the simplified radical. Remember the simplified radical? That calculator does it. Well, guess what that means? That means that's as simple as it gets. Right? So, it asks, does it form a Pythagorean triple? Well, I guess we need to know what a Pythagorean triple is then, right? On page 416, we can learn a Pythagorean triple is a set of three positive integers, ABC, that satisfies the equation c squared equals a squared plus b squared. So, positive integers means that, well, this would be three positive integers, right? 3, 4, 5, yes? Those are integers. Integers are positive, negative numbers, no decimals, and no fractions. Do we think that's a positive integer? Yeah. Or is this actually an irrational number? Irrational is not an integer, right? Does this translate into a decimal?
Yeah.
Yes. So an integer has to be like numbers like this. And they call positive integers, we might call them natural numbers, just normal counting numbers, right? So this would be not a Pythagorean triple. You can't have any radicals. To be a Pythagorean triple basically means that you're going to have real easy numbers like that. Okay? So that's 3. 5 is going to be basically the same way. Let's move on to something maybe harder. Well, this is my two answers. So let's move on to something that may be a little harder. Let's move on to 9. So 9 would be, we got a little triangle here. Okay, it's very important to be able to identify what the C is. And in this case, this is the C, right? Okay. So if that's the C, then our formula would be like 50 squared equals x squared plus 48 squared. This definitely feels like more of a calculator situation. And I put my calculator in a goofy place, somewhere. Do what now?
Oh, not 50 squared. 48 squared is 250.
Okay.
And 50 squared is 2500.
I'm bothered that I don't know where to put it. Put it somewhere. All right. Now I hear you. So, yeah, this is going to get some big numbers. All right, so this should be easy, right? Just subtract 2304. And we should get a number like 196. And let's see, square root. What is square root of 196? 14. And that's a bad way to answer it, so let's do like that. All right, what do we think? Is this a Pythagorean triple? 50 is a positive integer, 48 is a positive integer, and 14 definitely is not a decimal or a fraction, so it's a positive integer, so this one would be yes. So again, there's two answers. So that's that. Okay, and the next kind of problem is going to be on 15. And like this is the last example I need to do, which is going to be perfect timing for getting ready for the super exciting Gold Rush event of 2021, which is nice that we actually get to have events. Now that, the cases are so low, we get to have events. That's very, very nice. All right. Which number did I say? 15? It says, tell whether the triangle is a right triangle. Okay, that should be easy, right? So A, B, C is all I need. All right. Squared, squared, squared. All right, let's see what we got. The biggest number is 97. So 97 squared. And then I'm not sure what it's going to equal. And then we got, what, 65 squared plus 72 squared? So we're going to see what this is. So 97 squared is not the same as 91 squared. Wow. All right, 97, that's 904, that's what I mean, 65, and honestly you can just put that on the calculator if you want to. I'm not going to do it for the example, but you can. Because this is just calculator, and if it's just calculator you can skip stuff. I just like to do this just so you can correct me if I do something wrong. So I got 9409 equals 9409. What does this mean? That means it is a right triangle, so yes. Okay. So that's it. That's basically what we're doing today. This was supposed to be your Friday's work, which would be a nice little Thursday, Friday situation because it gets hard from here, but it doesn't start out hard. So put up your stuff, and